Hello, my name is Jonathan Ashdown, co-founder and CEO of Adept Advancements. Have you ever lost cell phone reception while traveling on a subway, driving through a tunnel, or riding on an elevator? That's because conventional wireless technologies, which use electromagnetic waves, are unable to communicate through these solid barriers. Wired technologies require drilling of holes, which is expensive and can cause leaks or structural failure to occur due to a reduction in structural fidelity. The third aspect of the problem is that sensors in hard-to-reach places rely heavily on batteries, and servicing is often difficult or unrealistic. The implications of these problems is that lack of wireless monitoring in hard-to-reach environments can cause major problems or disasters. Think back to April of 2010 when the British Petroleum Deepwater Horizon disaster occurred, killing 11 oil rig operators due to a malfunction in a blowout preventer at the ocean floor. They had no way of monitoring what was going on and were essentially, quote, deaf, dumb, and blind, according to British Petroleum oil executives. Another recent disaster that occurred due to lack of wireless monitoring was the Fukushima nuclear disaster of 2011. In this case, they actually sent men in bunny suits into the levels of highest radiation to monitor what was going on. In 2005, the Navy issued a mandate requiring that no new holes be drilled in the hulls of their high-value assets, including aircraft carriers, destroyers, and submarines. This led to a SBIR solicitation in which they were seeking methods to communicate wirelessly through metal walls. That's where Adept Advancements comes in. I founded this in 2009, and my doctoral thesis was to develop a breakthrough technology using ultrasound to transmit data and deliver power wirelessly through thick metallic barriers. Shortly thereafter, in early 2010, I came up with a successful proof of concept, and then in 2011, I came up with a working prototype, and then for the past 2 years, I've been conducting beta tests for not only British Petroleum, but also for the US Navy. Currently, I'm pursuing a part-time MBA while I am championing the business aspects of my company, and we're moving forward in earnest with the commercialization efforts of this technology. This is one of the first working prototypes. The basic idea is that there's a metallic barrier, and you transmit power through the wall and use energy harvesting techniques to store the energy on a large capacitor, which is enough to power all the electronics on this side of the wall without the need for a battery. This patent-pending technique, in addition to another technique which transmits data wirelessly through the wall, can monitor what's going on in hard-to-reach environments and relay it back to a safe location. This is another image of the system. This is the transducer that we use to send power through the wall and receive power through the wall. On the other side is another transducer, and we're able to power a 30-watt light bulb and send data through the wall at 18 million bits per second. To date, we have come up with several proof of concepts and successful prototypes. We've done well in business plan competitions, the Lemelson Innovation Award, and also have collaborated on SBIR grants. With also another piece of that is collaboration with academia. There are 5 patents surrounding this technology, and 2 have been granted actually very recently. And there are 3 still pending to protect the novel ultrasonic communications and power delivery techniques that we are using. We also have connections in big oil. British Petroleum was the first to knock on our door and say, hey, let's give you guys a little bit of money to work with and see if you can send information actually down the the drill string. So we designed a prototype to send pressure and temperature data down the pipeline, and we were successful with that. The success in various arenas and publications led other companies, including Chevron, Weatherford, and Schlumberger, to contact us, and they are very interested in our product as well, and have actually written us letters of intent that they will be ready to buy when we have a product to offer. For the past year and a half, I've also been working with the Navy to develop a working prototype and preliminary beta testing on hulls of ships and submarines. Moving forward, we plan to maintain collaboration with academic research to stay on the cutting edge, because that's very important to this high-tech area that we're in. We aim to fully commercialize the technology and collaborate with companies manufacturing complementary technologies, which will most likely be sensor manufacturers. Our business model, since it's a platform technology and it's compatible with all sensors and systems, is to provide not only a product but also a service. So we'll license it directly to manufacturers with a revenue sharing agreement, the percentages of which are to be determined. And then we'll also maintain installation and service contracts with companies who use our technology.